to the sandiness. They'll flow, but they still stick, and eventually they get out. So after 5 minutes, it'll get here. 15 minutes, it gets here. 20 minutes, it gets here. This is a little farther than the slow component because this really sticks to the sandiness. This does not stick as much. It sticks there, but not as much. This is a different component. We can try with a third one. A third one, this is, we'll call it the fast component. This one, again, the liquid flows through it. This component of the liquid, it's all dissolved. They're all dissolved in the liquid, but it's still in the liquid. So you put it over here, have that liquid keep flowing. After 5 minutes, this is faster. It gets all the way here. After 15 minutes, it's all the way here. That's like pretty far because this is a faster one. It does not, this component or this solute does not stick that well to the sandiness in the columns. So this thing, after 50 minutes, gets carried all the way here. After 20 minutes, it'll here. Maybe after 40 minutes, it'll be all the way out. So this is faster because this flows a lot faster through, through the sandiness, through the column. So imagine you're taking a solution. It has all three of these components. They're all mixed up in your let's say, whatever you get from the crime scene. So you take a tiny drop of it and you put it over here. Now, everything's mixed up. Put a tiny drop of it over here. And you flush it through with that liquid eluent, with that liquid solvent, or whatever you want to call it. It will flow. And remember, this one, the fast component, will be dragged through it. Again, they all stick to a certain extent, but they all stick to a different extent, to a different amount. The faster component, after 5 minutes, we see will get a little bit further than the others. They're still pretty mixed up. After 10 minutes, you can see the fast component was so fast, it outstripped the others, so that it's actually separated from the others. After 15 minutes, even the other two start to separate. And of course, the fast component is way more than the others. After 20 minutes, you see they're all separated. So if you're standing here with a beaker, as often happens, but you'll see what exactly we do with it. But you can certainly stand here with a beaker. You can separate every single component. After, let's say, 40 minutes, this thing will come out. You'll have your beaker ready to take it, then take the beaker away, and you've separated the fast component. Then after, let's say, an hour, you stand there and you get ready to take the second. And after 2 hours, you get the third. The point is you have separated every one of these components. Now, a lot of this depends on the solvent used. Some solvents will carry this thing even faster than this one. It can also depend on what kind of powder or sandy stuff you're packing it with. Some sandy stuff you pack it will get this thing faster than all the others. A lot of different possibilities. And they have many, many different, what they call protocols for separating various kinds of components. But the basic idea is there. That given a general column like this, that's packed in a, let's say with the, I was most familiar in my case with what they call a C18 column, but never mind what that is. But let's call it a C18 column. You flow things through it, everything will stick differently, and because of that, their speeds going through it will be different, and therefore you can separate. Even though they're all mixed up in your original sample, let it flow through this column, they will eventually separate. Different protocols will give you better separations or faster separations. We're not going to go through all that, but just understand the point. This is chromatography. Putting something through a column, each component will stick to it differently, and therefore they will come out at different times. And you can separate all the components of your mixture that you had originally. So back to idea with a crime scene. When you get some mysterious solution at a crime scene, you drop it in there, you let it flow through the column, and they will all be separated. They all come out at different times. Now, it's a little bit more complicated, but easier for the user, as we'll see. What we do, instead of actually collecting it, we have a detector that detects when things are coming out. We'll talk about how the detectors work, but let's let's assume the detector detects. So here's what we have. Again, we have our mixture that you get from a sample from the crime scene, let's say. Let that liquid eluent flow through it. Incidentally, it doesn't have to be liquid. We'll talk about gases, but right now we're talking about liquids because I think it's easier to visualize. Anyway, so you have your stuff, your solution over here. It's got all kinds of garbage and diluents and whatever impurities and the drug that you suspect is in there. So anyway, you put all that. You take a solution. Just again, it's a solution already. If not, you can just dissolve it. In any event, you take a solution, you drop it over here, start that thing flushing through. Start that eluent flushing through. What will happen is they will all separate, and one will pass the detector. Let's see, that will be this one. See, these are the shorter times. Let's say this is time 0, 5 minutes, 10 minutes, 20 minutes. Time goes, whatever it is. The one on the left is the longer time. Okay, because this one goes through first. That we'll call component C. Okay, this one goes through first. So as soon as it hits the detector, it says, "Hey, wait, I got something coming." So it's here 0, 1 minute, 2 minutes, 3, 4 minutes. Whoa, something's coming along. Something's coming along. Here it is. Here it's coming. Got a lot of that stuff. The higher this peak on your this is a chromatogram. Again, this is chromatography. The system, it's called chromatography, and this result that you get is called the chromatogram, right? It's a graph of chromatography, so we call it a chromatogram. Anyway, so first thing comes in the detector, says, okay, I got something coming. That is here, and here it's got a lot of it here. Then eventually it fades out because, it stops coming. So it gives you a peak. Here's where a lot of it comes. Then after, let's say, 20 minutes, nothing's coming in, right? Next comes the second component. It says, well, something else coming, not that much of it. That tells, not that much of it, because that's it's lower on the chromatogram, and it stops over here, let's say, an hour. Then, as time continues, this third one gets to the detector, and then it detects this is a little bit more than B, but less than C. So a couple of things we know. Number one, we have separated them. Number two, we know pretty much how much of each, certainly how much of each there is based on sort of the height, but it's more like the area of this peak on the chromatogram. This area is largest, there's more of it. This area is smallest, then there's the least of it, and then this is like right in between. So we know, so we have separated it, and we know how much, at least relatively, how much of each there is. There is also another aspect of this that we also can find. Let's say the drugs or the stuff that comes through. Now, what we can know, we can just put, let's say, over here. If we know that component 1 comes out in exactly 2 hours, as we tested it, we put, let's say this, we call this C. We call this A. If we know after putting an A in a test column, it comes out at the end, or gets to the detector in exactly 2 hours, and B, this is B, comes out in exactly 1 hour, and this thing comes out in 40 minutes, then we look at this chromatogram, and we can actually identify what's going on. Whatever's coming out after 40 minutes, that's got to be C. It's got to be this. So what's coming out in an hour? Well, it's got to be B. It's coming out, in 2 hours. It's got to be A. So we know what C is. We know we take a known sample of C, we put it through the column, and it comes out in 40 minutes. So we look at what's coming out. We see something coming out in 40 minutes. We know pretty much what that is. Something coming out in an hour. We know what that is. And the same thing for A. We know it's coming out in 2 hours. It's got to be A. So not only do we know how much of each, we also, by the location on the chromatogram,